Printing variations of an image in layers, then having light reflected from those surfaces at different angles is basically how you produce a hologram. Sound mysterious? Not for much longer.
A hologram is a three-dimensional photograph produced by the interference of two laser beams. A laser emits light, this light ray. The color of the light varies according to the wavelength. A shutter, when activated, either blocks the light ray or lets it pass through. Here the beam is split in two at a 90-degree angle. The interference of the two beams is clearly visible on this screen. It has very defined fringes. The beams need great stability because the pattern of interference projected on the screen is extremely sensitive to minute vibrations. A light tap on the table can easily spoil it completely. The team will create a hologram from this sculpture made of modeling clay. The sculpture is positioned on a support with a magnetic base which adheres to the metallic table. Then they place a glass in front of the object. Here's the exact point where the light beam passes. The table has to be perfectly stable, so it's made of a 2.2-ton block of steel, which rests on 18 air tubes. The table and laser are thus well insulated from all vibrations. The beam splitter separates the beam in two, directing one behind the object and the other in front of it. One part of the beam heads toward the front of the sculpture. The beam first passes through an objective lens, which diffuses the light. Then it's reflected by a parabolic mirror, which prevents it from losing too much of its intensity. As in photography, film is required. This holographic film is attached to a glass plate with adhesive tape. Then another glass plate is added so that the film will not move. A vibration of 1/10 of the laser's wavelength is tolerable. Now the laser is turned on. The intensity of its light ray reaches about 250 milliwatts. The normal exposure time of the model to the beam is about 1 second. But some holograms, made with a pulsed laser, are exposed to the light for 12 nanoseconds, an infinitely short period of time. Here we see the reference beam coming from the parabolic mirror. And here we see it from another angle. As in photography, the film has to be developed. These trays contain different chemical solutions and the developer. First, the film is soaked in the developer for 2 minutes. This solution blackens the silver salts, which have reacted to the light. Then the film is soaked in a solution called bleach to completely eliminate the silver salts, which blackened it. Now the film is rinsed. This step is used to eliminate the acids in the emulsion and to not contaminate the next solution. The film gently becomes transparent. It's then rinsed in clear water, and it's soaked for 1 minute in a wetting agent which eliminates all water spots. The film is then dried and it reveals its secrets. And here's the hologram created from the sculpture. A hologram really creates a three-dimensional illusion. Some holograms can be animated. They are generated from a series of still holograms. Depending on the complexity of the project, a hologram can be produced in between 1 and 5 hours.
Printing on packages isn't just the listing of ingredients or instructions. It's also the complex art of product identification, as well as creating an appealing, attractive look for the consumer.
All consumer products are packaged, and the making of these packages starts with the burning of an aluminum plate like this one. This animation illustrates the burning process, the transfer of an image onto an aluminum plate. The plate is placed onto a cylinder, and using a laser, the burning begins. The image appears in 6 minutes. This plate will make the printing impressions on packages. The laser which did the burning has to be perfectly calibrated using this test plate. The plate is now ready to make impressions via the offset method. Printing involves ink, and it requires selecting the right one. If the desired color does not exist, it has to be made up from a mix of various other colors. An ink trial is done with a spatula. And using this small manual press, color ink tests are done. The ink is spread onto paper and the color compared with the one called for by the customer. If the two match, the presses can be started up. This is a 6-color offset process printing press with a 72 by 108 centimeter capacity. The press is fed by a suction and friction process, devouring 8,000 sheets an hour. Now the printing plate is placed onto the press cylinder. This plate will contact inking rollers of the ink reservoir. To prevent it from drying, ink viscosity is maintained with this oscillator. The press starts up and reaches a production rate of 8,000 impressions in 60 minutes. The press comprises individual color printing units. The paper sheet passes from one unit to another, receiving a new color at each step. Here they register the colors, that is, the quality of the superimposition of the different colors. The final step is the folding and gluing of the boxes. This grooved plate makes folding point marks on the carton. And this machine does the cutting, the embossing, and stripping of the sheets at a rate of 6,000 an hour. The cutting die cuts the carton sheets and, together with the grooved plate, makes the folding joints. This sheet is slid behind the cutting die to equalize the cutting of the sheets. This enormous pile of 3,000 sheets is ready to be cut. The embossing press feeder handles between 6,000 and 8,000 sheets an hour. Rollers guide the sheets in the direction of the press. And here, the sheets are embossed by the machine. The precision of the embossing is then verified. Next comes the cutting of the sheets. This goes on at 8,000 an hour. The cutting unit strips and removes the unnecessary pieces, and the carton scraps are sucked up for eventual recycling. The scraps can also be cut away manually by using a hammer. And the carton end pieces are sent off for recycling. All that remains is the assembly of the packages. This high-speed gluing unit can make up 30 to 40,000 per hour. Gluing begins with the folding of the sheets, following the folding marks. The sides of the form box are then glued together. An average of between 5 to 8 steps are needed to fabricate a packaging box. Every day, this plant produces between 1 and 2 million boxes, requiring almost 4,000 tons of cardboard annually.